Hello everyone, it's Eddie the Magic Monk here. Recently, one of my subscribers asked me where are matrices used in real life. So I will give you guys an example of where it can be used to model the population of a particular species. And this is achieved using Leslie matrices or the Leslie matrix model. So what is the Leslie matrix? Well, just before we get into the maths, let's imagine there is a particular species of rats. Now, what do we know about the rats? So let's put the information that we already know in a table. So let's say we record the age of rats in years, and the age of rats can either be 0 to 1 years old, 0 to 1 year old, and then 1 to less than 2 years old, and 2 to less than 3 years old. Okay, so these are the age of rats, and let's assume that there are no rats 3 years old or beyond. Okay, so they're either 0 to 1, 1 to 2, 2 to 3, and no one beyond 3. Okay, so the next thing we're going to do is I'm going to write down how many rats there are in each age group. So the next bit of information I'm going to have about the population is the number of rats in each age group. Okay, and let's say there are 80 rats between 0 to 1 years old, and let's say there are 40 rats between 1 and 2 years old, and there are 60 rats between 2 and 3 years old. Okay, so what else do I know about the rats? I can see you guys are very interested. Let's say I then have the birth rate. The birth rate of rats from each age group. So what is the birth rate? What does the birth rate represent? The birth rate represents the number of... Now, one very important thing that I forgot to mention is that the Leslie matrix model can only be used to model female populations. Okay, and that is because it relies on the birth rate of each single person in the population, or each single unit in the population. So the birth rate represents the number of female offspring per female per year. Okay, so what that means is within the space of 1 year, which is what each age group represents, within the space of 1 year, how many rats does each female give birth to? Okay, and the answer, let's say it's 0.28. Okay, so you can also think of it like this. Out of the 80 females, 28% of these females will give birth to a new child rat. Okay, and then let's have a look at the birth rate for rats between 1 to 2 years old, and let's say it's 1.2. So what that means is, on average, each rat gives birth to 1.2 rats. And then let's say for for the age group between 2 to 3 years old, let's say the birth rate is 0.5. Okay, so on average, each rat gives birth to 0.5 rats. Okay, then the last bit of information I want is the survival rate. Okay, the survival, how do you spell it? Hang on. Yeah. Survival, survival rate of each of these populations. So what the survival rate means is that if we look at the first age group, the survival rate just means what percentage of these 80 rats will survive to move to the next age group, which is the next year older. So out of the 80 rats, only 0.51, so 51% of the 80 rats will move on to the next age group, okay, after 1 year. Okay, and let's keep going. So let's say in this age group, 1 to 2 years old, out of the 40 rats, 0.81, so 81% of the 40 rats will move on to the next age group. And because we are assuming that the oldest rat is going to be less than 3 years old, so therefore no one from here is going to move on to the next age group, right? Because there is no next age group. Okay, so this is all the information we have about the species, okay, about this population. So what Leslie Matrix allows us to do is, for example, we can ask the question, how many rats, how many rats will, or female rats, because this only works for females, how many female rats will there be in each age group after n years? N can be any number, okay, which is the cool thing about about matrices in general, right? Because now that you've put them in a matrix, okay, you can just repeat the calculation over and over again to find out the answer for any number of years. So how does that work? So basically we need two matrices. Okay, we need what's called the Leslie matrix and it is going to have the same number of columns as your number of age groups. So here we have 3 age groups, so it's going to have 3 columns. And then we also need to have the population matrix, or you can think of as the input matrix, which is just how many rats there are in each age group, and that is just going to have one single column with the same number of rows as how many different age groups you have. Okay, so let's put this information in our matrices. Okay, so first thing you're going to do is put the 80, 40, and 60 into your input matrix, or this is your population matrix. Okay, so you're going to put 80, 40, 60 into this population matrix. So let's highlight that. Okay, so now what do we do with the birth rate? Well, the birth rate is going to be in the first row of the Leslie matrix. So the Leslie matrix, let's call that L. It's going to have the birth rate in the first row, 0.28, 1.2, 0.5. You'll see why in a second. Okay, you'll see why that's in the first row in a second. Okay, so I'm gonna again highlight it. So this is over here. Alright, and then the survival rate, okay, what you're gonna do is you're going to put the survival rate for the first age group underneath the birth rate of the first age group, straight underneath it, and then you're gonna fill in zeros in the second row for the rest of the second row, and then you're going to put the survival rate for the second age group here, 0.81, underneath the birth rate of the second age group, and you're going to put it underneath the 0, so it's going to be over here. Okay, and you'll see why, and you're going to fill in zeros in the other 2 sections of that third row, and you'll see why we're doing this pretty soon. And then I'm going to label the population matrix as N, and this is how many rats there are right now. Okay, right now. So let's call it N1. Okay, how many rats there are in the first year? Actually, I'm gonna label it as N0 because technically the number of years right now is 0 because we haven't started growing it yet. So let's talk about how to get N1. Okay, let's talk about how to get find the population of rats, of female rats after 1 year. Okay, and this is called N1. So N1. So to find that, all you have to do is you're going to get the Leslie matrix and you're going to multiply by the population matrix, or the number of rats initially. So the number of rats initially multiplied by the Leslie matrix will give you the population matrix after 1 year. So how does this work? Well, let's do the calculation. I will explain to you how it works as we do the calculation. So So you can see here I have 0.28, 1.2, 0.5. That is the first row of the Leslie matrix. And the first column of the input matrix is 80, 40, 60. And the 80 represents how many rats there are in the first age group. So number of rats between 0 to 1 years old. Alright, so that's what 80 is. And if I multiply using matrix multiplication, which is the first row multiplied by the first column, and writing the answer in the first row of the result matrix, so it's going to be 0.28 times 80 plus 1.2 times 40 plus 0.5 times 60, which is 100.4 rats. So this is the number of 0 to 1 year old rats after 1 year. After 1 year. Okay, so how does that work? Well, if you have a look, firstly let's write the 100.4 in the result matrix. If you have a look, these are the birth rates. Okay, the 0.28, 1.2, 0.5, these are the birth rates of each of these age groups. So if you want to know how many young child rats we have in the next year, basically that's just going to come from how many new births there are from each age group. So from the first age group, 80 rats, 0.28% of that will become the new child rats, which will be added to the number of new births after 1 year. And then out of the 40 rats, 1.2 rats will be born for each of the 40 rats. So 1.2 times 40, that's how many newborn rats that the 40 rats will generate. So they will also all be added, and then 50% of the 60 rats in the third age group will become new rats. So then these are all added to the number of newborn rats, or the number of rats between 0 and 1 years old in the next matrix. So this matrix here represents number of rats in after 1 year. Number of rats after 1 year. Okay, so let's continue with that, and let's talk about the number of rats in the second age group. So 0.5100 for the Leslie matrix, and if you multiply the second row by this column, you write the answer in the second row, first column, and that will simply be 0.51 times 80 plus 0 times 40 plus 0 times 60, which will be so 0.51 times 80 is 40.8. There will be 40.8 rats in the second age group. So how does that work? Well, if you guys remember, the 0.51 is the survival rate of rats in the first age group. Okay, so 0.51, so 51% of the 80 rats will survive to the next age group. So if we multiply, if we put that in the second row, 0.51 times the 80 rats in the first age group, and that is going to give us 40.8 rats in the 1 to 2 year old age group after 1 year, because that's how many of the 80 rats will survive to go to the second age group. And then again, the reason why we put 0.81 in the second column, third row, is because when we multiply the third row by the first column, we will get 0.81 times 40. We'll get 0 times 80 plus 0.81 times 40 plus 0 times 60. So we will essentially only calculate the middle bit here. So that gives us 0.81 times 40, which is 32.4 rats in the third age group after 1 year. So you might say, well, all this just for 1 year. What if I want to find out in 30? Okay, well, you might think, well, that's a bit of a jump, so let's rewind. If I want to find out N2, basically that comes from L times N1, because if I want to find the number of rats at the end of the second year, I will multiply the Leslie matrix by the number of rats at the end of the first year. But where does N1 come from? Well, N1 comes from N1 comes from L times N0. So we have L times N0, which is L squared times N0. So if N2 comes from L squared times N0, if I want to know what N50 is, that will just be L to the power of 50 times N0. So the general formula will be, if you want to know how many rats there are after I number of years, you just have to raise the Leslie matrix by that power, by that number of years, times the initial population. So that's the general formula. Okay, I hope this video helps you guys. If you have any more questions, feel free to comment and I'll make another video to try and redeem myself. Okay, thanks for watching. See you next time.